Our patented process uses a bit of voltage and current amplification. It's a power amplification device. It's taking advantage of the ring transients that happen with the iteration of the coil and the magnet. That power is, two things happen. It's greatly amplified, but it is also conditioned and stored. We use programmatic resistors to set the value to which, once it reaches storage, the excess energy is dissipated. If you need a particular voltage output for your processor, that is what you want to do. So much of industry is intermittent. During the operation of a particular process, energy harvesting is available. When that process changes function or stops, the energy harvesting is no longer available. Here's where battery management and energy harvesting come together. An energy harvester with battery management to an IoT sensor puts you in a position to where you have devices that are extremely reliable and that have an indefinite life. So your return on investment, which would not be very large, is very high. Basic principle of lithium-ion batteries, they have a life. They have so many cycles. If you run them from full power to deep discharge, they will begin to become inefficient and begin to not last as long. It's an engineering principle. The lithium-ion battery is A, not overcharged, and B, not allowed to discharge below 80% of its value. That battery, theoretically, can last indefinitely. Some tests have shown 20. There's speculation of even 40-year runs of batteries as long as they're not discharged below this 80% value. The two things that the battery management does, and we have found a particular circuit that works very well with ours. We have an integrated system. It A, does not allow the battery to overcharge, because if the fan or compressor is really running and you've topped that battery off, it simply no longer charges it. And the IoT sensor runs purely off of energy harvesting. When the process stops, the IoT sensor continues to update the parameters that it's hooked up to. Running strictly off of the battery can run for some time before it even reached that 80% point. Should it reach that point, the energy management circuitry shuts the sensor off, and the power is restored. The battery is charged, the sensor is turned back on and reconnects with the hub. And this might happen, you have an industrial plant that has a 2-month outage. It's not, the information is simply not needed at that point anyway. We were talking about RF energy harvesting in the previous segment. Depending on the type of plant, you literally may never need a battery. You may have some storage capacitance and the low power sensors and the continuous RF field. It just wouldn't be necessary. In other situations where the RF field or the rotation or the vibration, it's intermittent, it would be very desirable to have the battery as a backup. The other thing the battery does is it allows you to use a little more power for longer data stream transmissions and higher iteration rates. And you could also programmatically have it when the process is running, you're getting high data rates. When the process is off, you have much lower data rates, so that the battery is able to assist the energy harvesting to give the little extra power that you might need.